So today we are going to start with the fifth part of this chapter, and in this part we will be discussing Newton's third law of motion and few examples to understand the third law. Then a very important and the last topic of this chapter, that is conservation of momentum, and then there are few numericals on this topic, that is conservation of momentum. So let us start with the third law. So first we will try to understand the statement. Okay, then I will explain you it in more detail using the example. So the third law of the motion states that when one object exerts a force on the other object, the second object instantaneously exerts a force back on the first object. Okay, it is similar to, like, suppose if a ball is thrown on a wall. Okay, if we are throwing a ball on the wall, so will that ball go and stick to the wall? No, the ball is to rebound back. Okay, now when the ball hits the wall, in that case the ball is applying a force on wall, right? But the moment the ball touches the wall also applies a equal and opposite force on the cricket ball or any season ball, like it can be any ball, right? So the force, what we can see over here, that the first object, that is ball, is applying a force, okay, on this wall, and the second object, that is the wall, is applying a equal force back on the ball, and because of which the ball moves in the opposite direction. Even in case of a carom board, you might have seen that when a striker hits the side, any uh, any boundary of the carom board, then the striker moves in the opposite direction. Yes, why? Because the moment the striker hits the boundary of the carom board, the striker applies force. Okay, the striker applies force, and at the same moment the carom board, okay, we can say the board applies force on striker. Okay, at the same moment the board or the surface of the board also applies a force on the striker, because of which the striker changes its direction. Okay, so you all are aware of this simple examples. So from this we can say that when one object exerts a force on another object, then the second object instantaneously applies a force back on the first object. Okay, and the point that we have to note over here is these two forces are always equal in magnitude. These two forces are always equal in magnitude. Okay, means if suppose a striker applies a force of 1 Newton on the side of the board or the boundary of the board, then the force applied by the board on the striker would also be 1 Newton, and it is always in opposite direction. Even in case of a ball, you might have experienced. Okay, so this is the definition, or this is the statement of third law. It can also be written like this: there is always reaction for every action in opposite direction and of equal magnitude. Okay, means what? Like, see, in this example of carom board, the force applied by the striker, that is the first force, So that would be termed as action. The first force is always termed as action, and the force applied on striker by the carom board is known as reaction. So there is always reaction for every action. Means if one body is applying a force on the other body, so that is the action, and in return the second body is always going to apply a force, and that is known as the reaction. And this action and reaction are always in opposite direction. This is very important to note, that they are always in opposite direction and they are equal in magnitude. Right? So that is what we can say in short, that action and reaction forces are equal and opposite to each other. Okay. And in if we are writing like this, that action and reaction, then for once it seems that first action is taking place and then reaction is taking place. Okay, but it is not true. Actually what happens, both the forces, that is this force acts on different objects and never on the same object, and it acts simultaneously. Means both the forces are acting simultaneously at the same moment. Both the forces are acting. Okay, so it is not such like that first action will occur and then the reaction will occur. Okay, that is wrong conception. The correct one is both are occurring simultaneously and they never act on the same object. They are always acting on the two other objects. For example, in case of carom, the one object is a striker and the second object is this boundary of this carom board, right? Now, though the action and reaction forces are equal, though they both are equal in magnitude, but these forces may not produce acceleration of equal magnitudes. Okay, now here it is given that the acceleration produced in the body is not equal though the force applied on both the object is same. See, for this we have to use the second law of motion. Like we know that the formula that we have got from the second law was F equals to ma, right? That can also be written as F upon m, right? A equals to F upon m. We can write it like A equals to F upon m. And from here what we can see, that m and A are inversely proportional. So for a body having more mass, the acceleration would be less. And if a body is having less mass, the acceleration would be more. Now just let me know that if a bus and a cycle, if a bus and a cycle hits each other, right? They hits each other. If they are hitting each other, then both are going to experience the same force. Say that the force experienced by the bus is also 40 Newton, say it is 100 Newton, and the force experienced by the cycle is also 100 Newton, because we have seen that the action and reaction are equal in magnitude. Because of collision, they both will experience the same amount of force. But will the both objects will move because of collision by the same distance? Is this true?
No.
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 Here what will happen? The cycle may travel a more distance and the bus may not travel even a few distance, or if it is going to travel, it will travel a very small amount of distance, right? But in actually it is not going to travel any distance, right? So what is the difference over here? Because for bus the mass is more and hence the acceleration is very less, but in case of cycle the mass of cycle is very less and hence the acceleration of cycle is more, even though the same force of 100 Newton is acting on them. right? So this is what explained over here, that uh, though the forces are equal in magnitude, but these forces may not produce acceleration of equal magnitudes. This is because each force acts on different objects that may have different mass. Okay, the acceleration completely depends. It depends on two things, that is force and mass. So here the forces are equal, but if the mass is going to be different, then of course the acceleration is going to be different, right? Now let us discuss few examples to understand that third law of motion. Okay, let us take a very simple example of a balloon. You all might have seen that when the mouth of balloon is kept open, okay, the mouth of an air-filled balloon is open, then the air starts rushing out, okay, with a force. The air starts rushing out with a force, and the moment the air starts rushing out, the balloon also moves exactly in the opposite direction. Okay, if in a room, if you will fill a balloon with air, and when you will leave it, you will see that balloon will start flying in random direction. Okay, now why it happens? It happens because there is a force, or the air comes out with a force. The air is coming out with some amount of force, right? So according to third law, the same amount of force is also exerted on the balloon, but in opposite direction. Okay, and that is why if the balloon is vertical, the direction of the balloon will move upward. But if suppose the balloon is in somewhat this direction, if the air is rushing out in this direction, then the balloon will move exactly in the opposite direction, right? You all might have done this, or you might have seen this. Okay, so
Yes, sir.
it also proves that if there is an action, so here the force applied on the air is the action. Okay, it is acting like the action, and in return the equal amount of force applied on the balloon by the air is the reaction. Okay, and because of which the balloon starts moving. Now the almost same concept is applied on the rocket. You might have seen that when a rocket leaves the land, okay, means when it just starts, a lot of gas is released from the rear end of the rocket. Okay, you might have seen this. So actually what happens in the inside the rocket, due to combustion of the fuel, okay, a lot of gas is produced, and that gas is allowed to eject out or to rush out. Then when these gas are ejected out, they are ejected out with a very high speed and with a very high force. So the force acting on the gas will act as the action. Okay, so as we know that there is reaction for every action, so in reaction, or the reaction force acts on the body of the rocket. Okay, and it acts exactly in the opposite direction, that is in upward direction, and because of which the rocket starts moving up. So if it is asked that how a rocket works, how a rocket works, then here we doesn't have to explain its whole mechanism in detail. We have to explain on the basis of this third law of motion, right? So what we can explain, that in a rocket, fuel is burned and this exhaust gas is expelled out from the rear of the rocket. Okay, expelled out means it is removed out or taken out from the rear end, means the bottom of end of the rocket. Then the force exerted by the exhaust gas on the rocket, okay, means the reaction is equal and opposite to the force exerted by the rocket to expel it. Means whatever force was applied on the gas to expel it, the same amount of force is applied on the rocket. Means suppose if it is experiencing say it is 200 Newton, then even the rocket will experience, or the whole body of the rocket will experience a force of 200 Newton. Okay, and because of this force, the rocket starts moving upward. And this force exerted by the exhaust gas, okay, that is this reaction force on the rocket propels the rocket forward. Okay, and this is how the rocket starts moving, or the rocket works. This one, an example of bullet and gun, is the most common example, and such kind of questions is also asked in numericals. Okay, now let us see what is explained in this example. Like you might have seen that whenever a bullet is fired, whenever a bullet is fired from a gun, okay, either this big gun or even the small pistols, whenever it is fired, there is a movement in the body of gun, right? The gun always tends to move backward. The gun always tends to move backward. Even in case of the tanks, you might have seen, okay, the tanks which is used in army, okay, even in those tanks, when there is a firing from the tank, okay, when there is a firing from the tank, then also the whole tank, or at least this pipe, it moves behind. Okay, you might have seen this in movies, that whenever there is a firing from either a gun or a tank, it moves behind. Okay, so even this can be explained on the third law of motion. Now actually what happens when a gun, we will study about the gun and the bullet, okay, right? So when a bullet is fired from a gun, we know that the mass of bullet is less, while the mass of gun is more compared to the bullet, right? So when bullet is fired, when a bullet is fired, then the bullet experiences a force. The bullet experiences a force, and the same force, the same amount of force is also applied on the gun. The same amount of force is also applied on the gun, but in opposite direction. Okay. Now, as we know that the mass of bullet is less, and hence the acceleration of bullet is very more, and hence bullet can travel a long distance. While the mass of gun is more, and hence the acceleration of gun is less, because of which the guns moves back with a less acceleration, or with a less acceleration. And you might have seen that soldiers, or the one who are using the guns, they keep the gun, they give a support to the gun from the shoulder. Okay, why they do this? They do this to stop the gun from moving back. Okay, they doesn't want the gun to move back, and hence they give a support. Okay, so that the velocity of the gun, or this movement of the gun in opposite direction, uh, when it is firing, that is known as direction of recoil. Okay, recoil means when the motion of gun in backward direction on firing, that is known as recoil. Okay, so this is the case of gun. The same force is applied on both the bullet and the gun, but in opposite direction. But because the mass of bullet is less, the acceleration is more. And in case of gun, the mass is more and the acceleration is less. Okay, and the gun also moves in backward direction. To give a, so to stop it, the gunman always give a support from his shoulder, right? And this uh, motion of a gun in backward direction is known as recoil of gun. Like, understood? So let us see that how we can explain this in words. So we have to write like this: that when bullet is fired from gun, it moves ahead, right? So by Newton's third law of motion, the bullet also applies same force on the gun in backward direction, that is in opposite direction. And due to this force, the gun moves back, giving a jerk to the shoulder of the gunman. Okay, and you might have seen that if a person or a soldier is continuously firing, okay, from a gun, then his hand and the gun is uh, it continuously gives a jerk. Okay, and that is what explained over here, that why it gives a jerk. It is giving a jerk because of the force, applied on the gun. That is a reaction, right? And this jerk on the gun, or the backward force applied on the gun, is known as recoil of gun. And here the gun moves back only by a small amount. Why? Because it is mass is more. Okay, so hope you all understood the example of the gun and
Yes.
bullet. Now, up till now, we have discussed two examples in which we discussed about the force and we saw that the magnitudes are equal. But in this example, we are using spring balance so that we can measure the magnitude of both action and reaction, and we have to see that whether they are equal or not. So what we have to do in this example, there's a wall that is rigid support and there's a hook in the wall, right? Now spring balance B is fixed into this hook, right? And from the hook of the from the hook of the spring balance B, spring balance A is attached, right? And then we are going to apply a force on spring balance B, right? We are going to apply a force on spring balance B. So when we are applying a force on spring balance A in towards the right side, then because this spring balance is fixed on the wall, it will try to hold its position, and it will it will apply a force in exactly opposite direction, right? In exactly opposite direction. So the force applied by us would be known as action, and the force applied by the spring balance B would be known as reaction, right? Now here we have to note the reading shown by both these spring balance. So if it is performed, we will observe that if suppose when we will apply the force, the spring balance will show a number. Say that it is showing 4 Newton. It is showing 4 Newton in spring balance A. Okay. So even at the same time, the spring balance will also show a force of 4 Newton acting on the spring balance B. Okay. If suppose if we are increasing the force, if we are applying more force, or if we are pulling it more hard, then the spring balance A will show 7 Newton. So if the spring balance A will show 7 Newton, the force on the spring balance B will also increase, and it will become 7 Newton, right? It will also become 7 Newton. So by this experiment, what we can conclude, that yes, the magnitude is always equal and the force acting on them are simultaneous. They both are acting simultaneously. Whatever there would be a change in first spring balance A, the same change will takes place in the magnitude of spring balance B. Okay. The condition is both should not have any kind of error, and if they are having error, both should have the same amount of error, only then, right? So to explain it in words, what we can write, that when a force is applied through the free end of a spring balance A, that is this force, it is observed that both the spring balance shows the same reading, that is 4 Newton and 4 Newton. It means that the force exerted by spring balance A on spring balance B, okay, it means the force exerted by spring balance A on spring balance B, okay, means over here at this point, the A is applying a force on B, is equal but opposite in direction to the force exerted by B on A, means this in this direction, the B is applying a force on A in the opposite direction but equal in magnitude. Okay, so this is what can be understood from the this example, that the magnitude is always equal and the force acts simultaneously and they are always in opposite direction. Okay, here in the first figure we can see that a person who is standing on a skateboard is applying a force on the wall. Okay, so will he move in the opposite direction? Yes, right, he will move in
Yes.
the opposite direction. Why? Because the wall will apply a same amount of force on him. The wall will apply a same amount of force on him. If he will apply even more force, then he will cover more distance towards this side, because the force applied on his body by the wall would be more. That would be equal to the force applied on the wall by him. Means if he is applying 5 Newton on the wall, then the wall will also apply 5 Newton in opposite direction. So these small examples that can be performed uh, explains that there is an equal and opposite force always acts when we apply a force on any one object. Okay, the same concept is used by the runners. You might have seen that the runners, when they take a start to run, okay, they always apply a force on this by their feet. They always apply a force on this that is in opposite direction, and because of which they gets a force in the opposite direction, which helps them to take a good start or to get a good speed in the first few steps, right? So they also uses the third law of motion to get a good start, right? So this is how the third law of motion acts on almost everywhere, whether it is in sports, whether it is in accident or something else. So hope you are clear with all the examples of third law of motion. Okay, now let us understand the last and very important topic of this chapter, that is law of conservation of momentum. Okay, so the law is the sum of momentum of two objects before collision is equal to the sum of momentum after the collision, provided there is no external unbalanced force acting on them. Let me explain you what does this statement mean. Okay. The statement, the first part of the statement is this: the sum of momentum of two objects before collision. As we know that if two objects, suppose if there is an accident between two vehicles having mass m1 and m2, which was initially moving with velocity u1 and u2. Okay, if the car is in motion or if an object is in motion, of course they will have some velocity, so let it be u1 and u2. So if I want to write the momentum of the first body, what I can write? I can write it as m1 u1, correct? That is the we know that momentum is the product of mass and velocity. And similarly for the second body, I can write m2 into u2, right? So this is the momentum before collision, the total momentum or the sum of momentum before collision, right? Now suppose they are colliding. If they will collide, okay, if suppose they will collide, then because of collision there is going to be change in their speed or change in their velocity. So suppose that after collision their velocity has been changed, and for the body with mass m1 the velocity is v2, and the body with mass m2 the velocity is v2, right? This is body 1 and this is body 2. This is m2 over here for this one, and this is m2 m1. So, and you all know that after a collision, of course, there is going to means the velocity is going to change. So if I want to write the momentum after collision, what I can write? For the first body I can write m1 v1, right? And plus for the second body what I can write? m2 v2. Okay, and it is given that from the statement, you see it is given that this is a sum of the momentum after the collision provided, and they are equal means it is given that they both are equal, and this is what we will derive this one, that why they are equal, this would be derived by us. And this is what the statement means, that is the momentum before the collision is equal to the momentum after the collision. It means, say that for some value of m1 u1 m2 and u2, say the momentum is 50 for the momentum is 50 before the collision. So even after, the value of v1 and v2 will change in such a way that on putting over here, again we will get 50, means there would be no change, both would be equal. And this is known as law of conservation of momentum, right? This is known as law of conservation of momentum. Hope you understood the statement and the meaning of this statement. Just give a yes in chat box if this is clear to you. We will do the derivation in the next class, right? That is tomorrow.